Hello guys, in this video I'm going to show you how to solve binary tree part sum problem. So given a binary tree and a number s, find if a tree has a path from root to leaf such that the sum of all node values of that path equals s. So as you can see here is our binary tree example, and there are three levels of this tree, so there are total 3 parts. Part must be from root to leaf, right? So here we can see there's total 3 parts: 1, 2, 5, 1, 3, 6, 1, 3, 7, right? So for problems that include something like level, then we should think of breadth first search, like the last problem we solved. But for this kind of problem where it mentions about path from root to leaf, probably 90% of you have to use depth first search. Okay. So for this kind of problem, I want to use depth first search and want to use recursion to implement it. But for recursion, we must identify the common problem and the base case, right? What is the common problem here? So the common problem here is that is there any path starting from current node to the leaf node, go all the way to the leaf node, let's sum up to s, right? So if we start at 1, we ask, can we find a path from 1 to the leaf node? Let's sum up to s, which is exactly our original problem, but because it's a GE, can you see the problem in other places as well? For example, if we don't care about this root node, right here we can ask, can I find a path from me, which is 2 to the leaf node, so that sum up to s, in this case 9 minus 1, which is 8. So we formalized the problem by that way, right? So additional, we can delegate our questions to left subtree and left child and right child, and recursively delegate the questions until the leaf node. And when we are at leaf node, we can, the problem will be, what the problem will be, until, for example, let's try it. For the root node, can I find a path from me to the leaf node, the sum up to 9? Okay, I'll ask my left child. Hey, left child, can you find a path from, can you find a path from you to the leaf node that sum up to 8, right? Left child say, okay, I'll see. Okay, I don't have a left child, so I will ask my right child. Okay, hey, 5, can you find a path from you to the leaf node that sum up to 6? Let's imagine that 5 doesn't know he is the root, he is the leaf node. So 5, okay, I don't, I am the root node. So the 5 check is value with 6, right? So obviously it's not equal to 6, so it will return the answer to 2 that we couldn't find for this path. We couldn't find a path sum up to S, right? 2 again return back to 1, right? So as you can see, we delegate problem and got back the answer. So that's how we delegate the problem to children node. So our problem here is, can we find a path from kernel node to the leaf node that sum up to some? So the answer is, if we can either find a path from a left child, if the left child to the from the left child to the leaf node that sum up to some minus me, which is root of out, or same here, I can find a path from my right child to leaf node sum up to some minus my value. Either 2 is the case, or return true 4. In total of 3 paths. If we can find at least one path, then it will be considered as yes. So one important thing here is the base case. Which is when is our problem stop, when our recursion stop. So our recursion stop when we are root node, which is leaf node, sorry, which means the left children, left child and right child is null. So if the left child, if we don't have left child and root not left and not right, it means we're gonna check, right? The two cases here we are leaf node. We simply check my current value if root of val equal to the sum, right? Return true, L return false, and this can be further these two lines can be shortened down to root val equal to sum. There's only one statement we can make it more clean. So how about this case? So we are to well, we couldn't find my left node, right? Couldn't find the left node. So it will not be the case. This one. So it will run down here. Delegate the problem to root.left, which is no. Then we recurse again, so that root is equal to no. In here we check no.left and no.right, so it will cause no pointer exception. So we probably want to add a safe check here. If we don't have root, just return false. So when we delegate the problem to left node of 2, which is no, we immediately return false. We come back to ask the recipe and so on. So let's run the test. Okay, it works. So that's it for this video. Thank you for watching. See you in the next video.